Okay, hi, this is Chemistry 111, Experiment 9, Determination of the Solubility Product Constant of Calcium Hydroxide. I'd like to believe this is a fairly straightforward lab without too much confusion, so let's have a look at it. Before the lecture begins, remind me to have you shake your saturated calcium hydroxide solution for 5 minutes before the lecture, then let it settle during the lecture. We'll be measuring how much of that calcium hydroxide's dissolved, so let's make sure we give it a good chance to all settle there, and then we will begin the lecture. The purpose is exactly what the title says, to find the solubility product constant of calcium hydroxide. We'll find out how much dissolved by titrating that hydroxide with that dissolved with an acid. Then we'll run the numbers to calculate the KSP. It's fairly straightforward. We can find the hydroxide ion concentration and calculate the KSP. I think I just said that. Okay, so here's a little background. Calcium hydroxide is only slightly soluble in water, so if you just take a bunch of it and throw it in water, most of it will settle to the bottom. That solution above it is by definition a saturated solution, so it's very easy to prepare that. That's the thing you'll be shaking. And here's what it looks like. Calcium hydroxide initially is a solid, but when you throw it in water, some of it dissolves into the calcium cations and the hydroxide anions. Because of its stoichiometry, you get 2 hydroxide ions for every calcium ions. Notice that the concentration of calcium will always be half that of the concentration of hydroxide. That's because of its formula. And this is the solubility product constant that people use, and it's a known number for calcium hydroxide. It's simply in solution at a given temperature, the amount of calcium ions in moles per liter, that's what those square brackets mean, and the concentration of hydroxide ions. Now this is squared. This is the way they've always dealt with this, so that coefficient becomes a exponent and we square it, and that's the KSP. You'll be graded on the precision of your number to the known value. Okay, here's the general procedure. I have left out some of the details now that we've been doing this many times now. Things like conditioning the burette, etc., are not listed in this procedure. However, fear not, because if you follow the listed procedure, it is basically cookbook, and you can just do what it says, and you should be able to get excellent results. All right, here's the one-sentence procedure. We'll titrate a saturated calcium hydroxide solution with acid to measure the hydroxide concentration. From there we can calculate the calcium ion concentration. From there we can calculate the KSP, bada bing. Here it is in a little more detail. This is much less detailed than what you'll see in the experimental procedure, but this is enough to make sense of it, so that I want to make sure you guys understand what's going on. So you shake that saturated solution of calcium hydroxide before the lecture begins, and then let it settle while the lecture is going on. We'll filter it also before we actually titrate it, just to make sure there's no precipitate and that it's all settled to the bottom. We will make a 0.1 molar hydrochloric acid solution. That's what we will be titrating the calcium hydroxide with. The procedure is given in great detail, and we'll use this to titrate that solution. Now, by doing that, we don't get a particularly precise measurement, so to standardize that solution, meaning to get its precise concentration, we'll do a titration of this stuff with sodium hydroxide. That's the first titration you'll do, and recognize that it has nothing to do with the calcium hydroxide. It's just to standardize the 0.1 molar HCl solution that you've prepared. So you have a precisely known concentration of 0.1 molar sodium hydroxide in front of you. Use that, put it in the burette, condition it first, and titrate that 0.1 molar HCl solution as the instructions dictate, and come up with the concentration of the hydrochloric acid, hopefully to at least 3 significant figures. Now you can precisely titrate your saturated calcium hydroxide solution. We'll be filtering it first. It goes into a flask. You drip in the HCl, condition it first. If that's the same burette that had sodium hydroxide in it before, you better rinse it a few times, run the HCl through it, make sure that it is a nice, precise HCl solution. And then you drip that stuff in. until it is neutralized. Calculate the concentration of hydroxide, then the concentration of the calcium ions, and then the KSP as we went over before. You will note that in the first one you have a base in the burette and you're dripping something in. You should get a nice color change with your indicator. In the second one you'll be titrating with a different indicator known as bromocresol purple, and it will turn yellow at the acid endpoint. Okay, here's the required calculations. There are 5 of them. 1, the concentration of HCl that you have standardized for each trial. This is an M1V1 equals M2V2 type calculation. Notice that you know 3 of the 4, right? You know the volume of the HCl you used. That is the amount that was neutralized with the sodium hydroxide that was dripped into it, so it's the amount in the flask. The molarity of the sodium hydroxide is given on the container. The volume of the sodium hydroxide is how much you dripped in through the burette, and then use that to calculate this right there, the molarity of the HCl, to as much precision as is called for in that titration. Nice, so you should have at least 1 or 2 trials. Calculate the average for me. That's calculation number 2. And then once you are doing your titration of the calcium hydroxide, find the hydroxide ion concentration. Same calculation, M1V1 equals M2V2, only this time you're solving for the concentration of the hydroxide. You should know the 3 other values: the volume of the hydroxide, the concentration of the HCl, and the volume of the HCl. So once you have that, that's the concentration of hydroxide. Use that to calculate the concentration of calcium ions that must have been present. Notice the formula is CaOH2, and for each calcium ion there are 2 hydroxide ions. And finally, calculate the KSP, which is defined as, that should be an equal sign, not a negative sign. Make a note of that. The calcium 2 plus concentration times the hydroxide ion concentration squared. You'll be graded on the precision of that data. Read the burettes always to 2 decimal places. The bromocresol purple will be going from purple to yellow when you titrate it with acid, and we're filtering that saturated solution to make sure no precipitate is present. It says so right here, and remind me to demonstrate that filtration for you. It's just a gravity filtration. And we're starting to get a little slack here now that spring is coming in, so be aware. No fake goggles that are just glasses. You must wear the real goggles, and please don't ask me to borrow pairs. You need to have your own pairs. No sandals. You must wear closed-toed shoes. No shorts. You need to wear full leg coverings, pants. If I see that your pre-lab is not done and you came in here with nothing, that's unsafe, and I cannot let you perform the lab. So I hope you understand those rules. Let's work safely. That should say work safely, and enjoy. I will see you Tuesday evening. Final note, as you are aware, there will be a quiz. It is of the same format as all the previous quizzes, and if you understood everything in this screencast, you should be in good shape.